In this video, we'll do another example where we convert a sentence in words to a logical statement using quantifiers and operators. So the sentence says, no one likes a sleepwalker, not even themselves. And I want to do this in the framework of the last example from our previous video, which was let the domain of x and y be SU students. R of x comma y is x is related to y. L of x comma y is x likes y. And S of x is x sleepwalks. So when I look at my sentence, I see something about, someone liking someone, a sleepwalker. So that makes me think that we're going to be using this propositional function for x likes y, and probably this one for x sleepwalks in our problem. Okay, so let's break this down. So when I see a sentence like this, that seems to involve quantifiers, I first like to rewrite it to really make it clear and explicit where the quantifiers are. So the words no one, well, that's the negation of there is someone. So the negation of a there is quantifier. So I can write there is no, and the person we're talking about for this problem is a student, because that's the domain of my variables. There's no student, SCU student. Let me introduce a variable to talk about that student. So that's going to be the variable that goes with this there is quantifier. There is no student x. And then I can write like for which, or maybe such that, no student x for which. And now I need to somehow introduce sleepwalker into the mix. So I need to be saying something like, for which someone out there who's a sleepwalker, that person will not be liked by this first student. So let me focus on that language a little bit. Someone out there who's a sleepwalker. That's kind of suggesting, like, I'm going to use a there is, for which, there is someone out there who's a sleepwalker. So for which, how do I say that? So there is, I can't directly say there is a sleepwalker, because the domain of the variables that I use aren't sleepwalkers, they're students. So what I can say is for which there is a student, okay, and I'm going to introduce a variable. And I can't use the same variable x because that would be kind of assuming that the two people are the same. So I'll use a new variable y. So for which there is a student y, such that, so s.t. is my abbreviation for such that. And now I need to assert a couple of things. I need to assert that, the student y, I'm introducing them to be our sleepwalker. So I need to assert that y is a sleepwalker. And, so there's a key word there, and that x, student x, is not going to like y. Okay, so to assert y is a sleepwalker, I will say y sleepwalks. Y sleepwalks. And then I have a connecting word, which is and x likes y. Okay, because I don't want that to happen. I said there's no student x where I want this to be happening, where y is going to sleepwalk and x likes y. I want to notice that I haven't really used this phrase yet, the not even themselves. But all that really means in this context is it's okay for the x and the y to be the same. Because even if they were the same, we'd just be saying then in that case, the sleepwalking student doesn't like themselves. Okay, and what that does for us is it allows us to avoid the situation, like in the previous problem, where we had this word other. The second student was different from the first student, and I needed to use a phrase like this, y is not equal to x. Essentially, I don't need to worry about that in this problem, which makes it easier. Okay, so we're ready for some quantifiers. So I have the negation. There is no student would be the negation of, and I get there exists x, for which there's a student y is there exists y. And then I'll put a bracket, and then I have my and statement. So my and, the first part of that is y sleepwalks, s of y. And then x likes y would be L of x comma y. And we got it. We got it. For practice, let's try using our De Morgan's laws. If I have a negation in front of quantifiers, I can move it inside the quantifiers. And when I do that, it flips each of the quantifiers. So the first there exists turns into a for all. The second there exists turns into a for all as well. And now the negation has moved inside of them. I'll put a parentheses, and then I got my s of y and my L of x comma y. I can use my other De Morgan's, which says if I have a negation and in front of an and statement, I can move it inside and distribute that negation to each part, and that'll flip the and to an or. So that'll give me for all x, for all y, and then I'll get the negation of s of y, the negation of L of x comma y. And then the and switches to an or. And that's another equivalent way to write this.